In this lecture, we are dealing with conversion of an NFA to a DFA using subset construction algorithm. As the name indicated, subset construction. In this algorithm, we are going to generate a subset of states from the given state of given NFA. As we know, the input for this algorithm is a given NFA. The output for this algorithm is a DFA, which is accepting the same language as given NFA n. In this method, what we are going to deal with is we are going to generate a DTran for the DFA. DTran means it is a transition table for the output DFA D, in which it is constructed from the set of states of given NFA, and what we are going to simply consider is epsilon transitions of n properly in such a way that it generates subsets of states of given NFA. What we are going to simply consider is epsilon closure of given state S, which is nothing but set of NFA states reachable from NFA state S on epsilon transitions alone. Epsilon closure of capital T is nothing but set of NFA states reachable from some NFA state S in set capital T on epsilon transitions alone. Same way, move capital T small a means set of NFA states to which there is a transition on input symbol A from some state S in T. Take a simple example. What we are going to consider is a regular expression. For that one, we simply got an NFA with epsilon transitions. What we are going to simply do is we are going to convert this NFA to the desired output DFA. For that one, what we have is epsilon transitions. First, we have to define the epsilon transition. Epsilon transition is nothing but by applying epsilon on any state, if there is any transition of given state by consuming the symbol epsilon and transfer to another state, then we are going to say that the transition as epsilon transition. For example, given state 0 on epsilon reaches 1. Same way, given state 0 on epsilon reaches 7. That means simply on epsilon 0 have 1 and 7 as epsilon transitions. Same way, a multiple transition on input symbol from state S in T. That is nothing but move T comma A. For 0, as we already know, it is 1, 7. On 1 also there is further recursive epsilon over there. That means 2. On 1, 4. That means 0, 1, 0 on epsilon 1, 2, 4, 7. That means there is no barrier of having 1 epsilon and 2 epsilon or 3 epsilon. Epsilon, number of epsilon is same. Though it is 2 or 3 on a consecutive space, it is epsilon. That means simply epsilon star is nothing but epsilon. Epsilon star is nothing but epsilon. On 0, 0, 1, 2, 4, 7, by default, every state by default itself is considered as a epsilon transition. That is why 0 is also included. For 1, it is 1 to 4. For 2, it is 2. For 3, 1, 2, 3, 4, 6, 7. For 4, it is 4. For 5, 1, 2, 3, 1, 2, 4, 5, 6, 7. For 6, 1, 2, 4, 6, 7. Same way. For the given state 0, it is 0, 1, 2, 4, 7. On that one, what we are going to simply apply is input A and B of the sigma, which is nothing but a set of alphabet. By on A, capital A and small a, we have a further definition epsilon closure of move of A comma A By that one, what we have is 1, 2, 3, 4, 6, 7, 8. Move of A, capital A and small a is nothing but 3, 8. Epsilon closure of 3, 8 is nothing but 1, 2, 3, 4, 6, 7, 8. That is in the same way what we have is another state called B. Same way on B, what we have is C. Same way we already completed for A, both small a and B. Same way we have to go for capital B, small a and B. Same way for capital C, A and B, we have to calculate the same thing. Same way for D, same way for E. Then ultimately what we have is a transition table that contains the entire states, which is nothing but a DFA. DFA generated, that is going to be simply converted as a given transition diagram. Thank you very much. This is a simple procedure.